Ευχαριστούμε πολύ στους συναδέλφους. Επόμενη παρουσίαση, next presentation, Vaios Karastathis to talk to us about NIX and NixOS and reproducibility.
Good afternoon, everyone. How many non-Greek speakers do we have? 1, 2, 3? If you want, I can speak in English. For you. Okay. So, I don't want to... where I work, I'm used to take the blame for things that I'm not to blame. So you can blame me because you will delay your beers afterwards. I don't want to disappoint you, but this is not about internet exchanges. IX is very popular letters today. It is something about close to the previous presentation. I'm Vaios, I came from Patra for this presentation, and I also want to thank Mr. Theodoros Karounos, because 1 month ago I presented this as a workshop in the National Technical University of Athens, and he encouraged me to send the presentation proposal for this conference. So, let's see the contents. We'll talk very fast about what is NIX, where it came from, its core characteristics, a little bit fast, and then we will see how it builds stuff and some tools that it provides, and about NixOS and how you can manage infrastructure with NixOS. And at last, some advantages and disadvantages that it has. So, NIX is a functional language, so you can write functions for anything that you want. If you design those functions to output configurations for anything, it's just a language to write functions. If you design those functions to give you packages in the outputs, then it's a package manager. Okay. So it works in any Linux, it works in Mac OS, and for eccentric people, it also works in Windows subsystem for Linux. And it has multi-architecture support, x86, 64, ARM, and i686. And if with this functional language you want to define a full operating system, you can define it and it becomes NixOS, which is a full Linux distribution based on NIX. So you are going to, in the NIX ecosystem, the NIX term is used interchangeably between all these things. So it's all these three things. And where it came from, it was built before 2010, 2003, 2004 as a PhD thesis from Mr. It's written in the right, Mr. Ilko Dolstra. He's Dutch, and he built NIX as his PhD thesis in the Netherlands. And the problem that he wanted to solve was the broken dependency chains, version conflicts of dependencies to build stuff, and ultimately eliminate this problem that you build something, it works on your computer, you give it to someone else, and they say, oh, it doesn't work. Good luck. So with NIX, this doesn't exist. Core characteristics. Every dependency for everything is declared in advance. You have to strictly define what is going to be used to build anything. So packages becomes functions. They take inputs and they give outputs. If you strictly specify the inputs, you will have every time the same output. Every time. It builds things in isolation, so it fetches all dependencies, and then the actual build process is running in a sandbox automatically. it cannot fetch stuff from the internet live at the build process. So it's secure. And the result is that you have packages that cannot be, we call them immutable, but the thing is that they cannot change. They are built and they are the same. If you want to make a change to them, you have to rebuild them with different inputs. So this gives the first main, I don't remember the word in English, the first idiotita, the first property of NIX, that it makes stuff reproducible. Okay, so if it works in my machine, it works on yours, it works on yours, it works on yours, everyone's machine. So how it builds stuff? This is the one of the two slides that I have code, because I don't want to burn you. So I will give you a generic build pattern. This is the super simple thing. Let's say we want to build my application, and I have packaged the code in a tarball, okay, somewhere. Okay. With this function, I declare that this is the source. I have also to specify the hash of it, because we have to know exactly what are we going to build. And then we have to use the specific build inputs. We can use as many as we want here. We can specify native build inputs, which is dependencies that are going to be used only in the build process. These inputs will be available to the result when it runs. So it will also be running reproducibly. These inputs will be used only during the build process. And then we can define configure phase, install phase, custom phase, whatever we want, which they ultimately can be small script snippets if we want. The result, everything that is built goes to this directory, /nix/store, everything. Whatever it is, it doesn't matter, it goes there. Everything goes with its hash in the beginning of the name. It has the hash, so we know exactly what we have built. And then it's the name and the version of what we have built. Everything that is inside the NIX store is not writable. If you want to change it, you have to rebuild it with different dependencies or with a different source. And then it will have a different hash. Simple. So the result is that NIX is the biggest and most complete package manager in the world. In this link here, in NixOS.org, be careful, do not visit NixOS.com. It's something completely different. Please don't do it. So in this link, you can find every package that is available to use with NIX. And they're all defined in one single GitHub repository, NIX and NixOS, which is it's available on GitHub, it's open source, and the thing is that every new version is just a new branch of this repository. So it's that simple. Bonus slide. Let's say you want to define a development environment for stuff that you build. Let's say I have written a Python script, and I have used it in Python 3.12, and I want to check if it will work the same way with Python 3.14. Okay, I just type this command, and I magically go into a different shell in the same terminal, nothing changes, and I have available Python 3.14, and I can run my script to see if it works the same way. And then I exit it, and I'm back to my normal environment without polluting my system with another version of Python. The same thing is for anything, because I have put here the example with Node.js and stuff. And so if I want to build more complex stuff and share it with other people, it all can be shared with one file. So I can tell NIX in a .nix file, use the NIX packages, the repository from NIX packages, use these packages as inputs to be available in the cell that you run, and when someone enters that cell, run this command to say hi. So if someone takes this file and runs it with NIX in their machine, they will have immediately available these packages and what to run them. And then if they exit, these packages disappear from their environment. They don't disappear from the hard disk. Okay. So this is the second property. Everything becomes declarative and shareable. And now let's go to the next level, and I'm right on time, I think, because we said defining packages, defining development environments. We can take it to the next level to define our whole operating system, everything. And by everything, I mean really, really everything. Users, environment packages, user packages, system services, user services, networking, interfaces, firewall rules, whatever you want, file systems, and even there are tools to define what will be included in users' home directories. You can go that far. So to achieve this, there is some slight modifications in the traditional file system structure of Linux. I will show it afterwards. And everything is managed from one file, not weird configuration stuff in I don't know where. The default location for this file is the /etc/NixOS configuration.nix, but of course you can have it anywhere you want. So I suppose most of you are familiar with this tree. This is the file system structure of a traditional Linux. We have all these directories, home directories, and possibly other stuff. So you have configurations in /etc/bin in the var directory. You have to install packages manually with whatever package manager you use. And whatever you change, you have to write it somewhere so other people know what change you did. Because otherwise there's no documentation. So in NixOS, we have this file system structure. These are the key directories. The same principle with the simple package manager is that everything is in Nix store. Everything. And I mean everything. So in the etc. NixOS directory is the configuration. If you want, you can have it elsewhere. That's the default. The /run directory is a symbolic link to the NixOS, to the Nix store, the Nix store. And of course, we cannot get rid of the boot directory because we need it. The home directories. This directory. Okay, we need it because we can store there databases and data directories for services, whatever. And all the other directories, the bin, sbin, lib, whatever, they are symbolic links to the Nix store. So we don't deal with that stuff. They are empty, or they only contain one link to the store. So how do we define it? You don't configure, you describe what you want, and you describe what do you want it to have. So this is a very simple, very small example of a configuration. Okay, so you define the bootloader. You can have any other you want. Hostname, firewall. This is an example. You can define other options in firewall. You can, if you want to run a web server, you just enable it. You can define users and a user what groups will be in. The will group is a pseudo group in NixOS. Or you can define anything there. And what system packages you want to be available in the environment. If you want this user to have packages only for them, you can add packages here. You can define everything. And where you can find all these options. You can find them in the same link as before, nixos.org. It's the packages and options here. There are more than 20,000 available options for pretty much too many stuff, for databases, for web servers, for file systems, to auto-mount stuff, to run systemd services, to whatever you want. So it's really huge. But you can search, it's searchable with text, and you can choose what options you want to put inside your configuration. And what's the workflow, the magic NIX workflow? First of all, you say how you want your system to be, whatever it is. And you write it in this file. With one command, you deploy it. And I say here anywhere because it can be Amazon Cloud, it can be Google Cloud, it can be a bare metal, it can be Raspberry Pi, it can be a Docker container, it can be whatever you want. VPS stuff, anything that can run Linux can run NixOS because it's just Linux. So with one command, you apply the changes to the system. If everything works as expected, you're okay. If something is wrong, you can roll back with one command. You don't have to check the state, different state files that were mentioned before or other stuff. You just check your system if it works the way you want. If there are errors, you just, with one command, you go back to the previous state. The system starts running with the previous configuration, everything is good, and you go back to change your configuration to see what was wrong inside it. And if everything is good, then you can reproduce it and you can deploy the same configuration to any machine you want. You can build it in this laptop and deploy it elsewhere. You can build it elsewhere and deploy it in this laptop. You can build it anywhere and deploy it anywhere. It's very flexible. So this makes it the third property of NIX. It's reliable because when you upgrade something, cannot break other packages because every package uses its own dependencies, and it always allows you to roll back. Whatever change you do and you see problems, you can always roll back, no problem. So the advantages of this, and some of them I wanted to focus, but the first one is security, because every package runs independently, has its own path, which is its own dependencies, so it's isolated from every other package. Every systemd service is strictly defined, so it cannot use other binaries in the system, whatever. Safe upgrades, I mentioned it, I don't want to lose time on this. And I want to focus on this concept because it was mentioned before, infrastructure as code, because it takes it on a whole new, different level, this concept. NIX is taking this concept in a different level because, okay, if your configuration.nix file is very big, you can have it in different files to use them, but everything will be one directory, one Git repository. You have full version history, you know exactly what change you did and what were the results, and you can deploy anywhere. And I don't want to be offensive because NIX is not offensive to Docker or other container stuff, because of course you don't need extra internal networking to manage container networks, but you can define in your configuration.nix, you can define containers, how you want them to be, what images you want them to run and stuff. So you can deploy them massively with one command. Nothing is perfect. One thing is that you have to, it uses slightly more disk space because it has to keep all the dependencies for every package that you have. So 5, perfect. Every dependency for every package has to be stored in the NIX store. Of course, there are tools to clean garbage when you don't want them. And the most difficult part is the learning curve. I have a meme in the next slide for this, because you have to learn and change the way you think to learn it. Does it worth it? I don't know. If you want to eliminate these issues, it's worth it. If you want to deploy with confidence and sleep at night without notifications, learn it. You can roll back, you can scale it massively, and I think it pays off in time. So, to be honest, this is the learning curve for NIX. I have been studying it for 2 years. I'm really somewhere here now. I'm not even here after almost 2 years. It's the steepest learning curve. Everyone in the NIX world agrees with this. So change stops being scary once you can recreate your whole system with one command. Thank you. I suppose we have 2 minutes for questions. I achieved it.
Okay. You have questions? More than enough.
Hello. I'll stick to English. Thank you very much for this, but NIX was one of the things I busted my head off, and I finally gave it up. So, its promise is excellent. The practice, however, is far from being viable. We can discuss it. Will you come to the beer afterwards?
Yes.
Okay.
There
I propose to take it
one
there.
small answer for everyone to listen. It's a valid proposition. Most of the people generally agree to this, that the documentation, the official documentation of NIX is not good. Okay, so you have to find your own way to learn it. I used YouTube. I used AI. AI didn't help. I used countless hours, and the most easy way to learn it is to try to build something yourself. I have built 2 projects. It's open source on GitHub. But if you want what you want to do, then you know how to do it with NIX. Okay.
You got to the next question. So you actually wrote NIX yourself. You tried to package something.
I have a package, the peer-to-peer networking tool, and the self-hosted cloud solution.
Okay.
Everything with one command.
So,
really? Yes.
Really cool presentation, thank you. It is unclear to me the following thing. So let's assume that I have a fleet of 200 machines, and with a single, let's say, description file, let's call it that way, I can ensure at least some compliance regarding some regulation stuff, and I can prove it even to the auditors and the like. What is unclear to me is not that with a single command I can make the machine compliant to the description or something, but how do I make 200 machines compliant? Do I need to invoke Ansible in order to invoke this single command in every machine? Or is there an agent that's listening on every one of those 200 machines?
Yeah. First of all, you have to, these machines need to run NixOS. Okay. Then you have if let's suppose they run the same configuration times 200, you say rebuild in your computer, and you specify as target host each one of them. So you build the configuration locally. What you build the contents of the NIX store. And then it automatically connects with SSH to each one of the machines.
So it does something similar to Ansible. So it connects to every machine and...
Yeah, with SSH. And it says, okay, we have a new NIX store now. Take it, run.
Thank you.
Question? Any question? Questions?
You know, how this is different from a combination of vagrant files with Ansible. I mean, originally, something like 15 years, vagrant file had the ambition to have idempotent OS, and for packages, it inherited either Ansible or even Docker files in there. So you had one vagrant file that produces the same, let's say, result. Okay, this is the enclave of that is a virtual machine. Okay, it's not a directory or something like that. How different is this in terms of result is NixOS?
I haven't used Ansible, but does Ansible build packages?
Yes. You can have. You can say that I want to have. It has roles. Basically, it has what's called Ansible Galaxy. So there you have. How to say that? Roles.
That's he's correct. Yeah, he's correct. He's correct. Yes, for the
mic.
He said that NIX does take care of the code, the infrastructure as code. You have to deploy it yourself.
What is the value out of that? If you have to deploy it yourself, because okay, we may discuss.
Deploy. I mean, you cannot automate the deployment with custom tools. Okay. So I suppose your question is, I have the configuration. How do I put it in 200 machines?
No. Basically, in any case, I mean, does not relate to the previous question, because the combination of a vagrant file and Ansible builds every time the same machine. Okay, so you start from let's say something like a base image or even that, and then it goes command by command or package by package and builds something finally. So in terms of final state, it's the same. What I see as a big bonus is that you can have incremental builds. That's
I think I understand your question now. When you rebuild something, if you already have it in the NIX store, you don't rebuild it. Is it closer? And you give to the other machine only the new stuff. Maybe we can talk later if you want.
Yeah. Let's continue the social. Thank you, Vaio.
One last question. Last.
We're pushing it.
Last.
We're pushing it, so everyone is tired.
I am to blame for the late beers.
Hello, thank you. Quick one. I couldn't understand if you install NIX on top of already installed Linux. Is my assumption correct? Because you showed one presentation that you can install in WSL.
Of course, you can use NIX as a package manager for Ubuntu, for Debian, for Mac, whatever, without using NixOS. Just to define packages, development cells, whatever you want. User services, home directories. Yeah, some people call it JSON with functions. Yeah, the actual structure of the language is simple, but the mindset behind it is difficult to get. This is it.
Right. Thank you, Vaio. Thank you again. Sorry to interrupt the lively conversation, but I know everyone it's late. Let me switch to this mic.